In this video, we're going to continue topic 6.9. We're looking at U substitution. And in this particular video, we're going to talk about inverse trigonometric functions in integrating them. So it says there sounds if we're going to learn like how to take the integrals of expressions that contain inverse trig functions, but it's actually opposite of that. We're actually going to integrate expressions and they result in inverse trig functions. So we are looking at, there are some that are more prevalent than others. I would definitely make sure I knew sine and tangent. The others are, there's a typo actually on the, oh no, they're not. There's no typo. I was looking at this thinking they were the other six. One of them is the basic form and one of them is the U substitution form. We don't typically see secant. The other three do exist. We just don't typically see them very often, so that's why they're not listed here. So you're looking for this basic form, something like 1 over 1 minus square root of 1 minus x squared, 1 over 1 plus x squared, 1 over the square or x square root of x squared minus, when you're looking for those basic things, okay? And then when you go to integrate them, they are, you have 1 over a for both tangent and arcsecant. And then it's always u over a for arcsecant, its absolute value of u over a inside the piece of trig. So it's basically just a formula that we're going to fill in. So on this first one, it's pretty straightforward. There doesn't look like there's any like goofy u substitution or anything like that. So we're just going to figure out what's a and what's u. So it looks like my a is going to be 2 because that would be the square root of 4, because this would be a squared right there. And then u is going to be the x. And then that means that technically that du is equal to dx, but I don't really need to worry about that on this one because I'm not really going to use u sub. So I know that I'm just going to do a straightforward integral. It looks like with the format that it's fitting is arcsine. So we're going to do the arcsine of u over a. I'm just following this formula. So u is x, a is 2, plus c. All right, looking at this next one, it looks like it's a little bit more complicated. This is the a, this is the u, or a squared and u squared. So we know that a squared is equal to, sorry, a squared is equal to 2. That means that a is equal to square root of 2. If u squared is 9x squared, that means that u is 3x. That's terrible. I can't write that on top there. U equals 3x, meaning that du, so think of this as something I should have written in orange, du is equal to 3dx, meaning I need to multiply top and bottom by 3 because I am missing that in order to do the substitution here. So let's look at that again. So I'm going to do my good old u substitution. We've got the integral of 1/3, and I'm going to put that 3 on the inside. If you want to put the dx on top, that's fine. And I'm going to rewrite it as 2 squared plus 3x squared. And then we've got the dx. I really don't need to worry about the u substitution almost because I kind of have it inherently built in there. If you want to do the u substitution and put a u in there instead, that's fine. But as long as we've got the 1/3 in front, it's going to work out. So we're going to integrate. So we keep the 1/3. It's in the format of arctangent, right? Because there's no square roots. So we know that when we integrate, we get arctangent. And then we plop u over a into arctangent. That's what it says. So u is 3 over x. A we said is the square root of 2. And then plus c. And I have something wrong because arctangent is 1 over a. I missed that. So I have to put the 1 over a in front there. So it's really 1, 3 square root of 2, arctangent of 3x over square root of 2 plus c. All right, let's take a look at this one. So this time, this is the u squared, this is the a squared, right? The u squared always has the variable in it. So that means that u is going to be equal to 2x, and that a is going to be equal to 3. So du is equal to 2dx. So this would be kind of like the regular u. This would be more like our 2x. So I'm going to have to multiply top and bottom by 2, meaning I'm putting a 2 on the inside. So I'm going to rewrite a little bit. So we have 1/2 2dx over x square root of what is it they do? Actually, on this one, it's a little bit different even. I actually need the 2 on the top and the bottom this time, because this piece right here is supposed to be the u, right? And look at what it is. It's not the u, it's only the x. It's missing the 2. So we are going to move the 2 inside there. Take it off the front here. And then I've got my u squared, which would be 2x squared, and then minus 3 squared. All right, it's set up perfectly. We don't really have anything additional, and we're definitely getting this arcsecant. So when I integrate arcsecant, I get 1 over a arcsecant. So 1 over a we said is 3, arcsecant of the u, absolute value of u, which is 2x over the a3 plus c.